say my paper ID is 718.
Hello, good afternoon. Am I audible to you? Hello.
Yes, sir, you are audible.
Oh, great, great. So, Dr. Brendra is here. Dr. Brendra. Dr. Brendra, our external chief guest, Dr. Sorry, actually, it was, I think something was wrong for assignment of the time. Myself, Dr. Shankar Singh, hosting this session as an internal. And just 1 minute. Yes. Hello.
Yes, sir. Good.
Yeah, please 1 minute. Yeah. First, Ashish Bishnoi is here.
Yes,
Ashish.
sir. Yes, sir.
Very good. And Dr. Shailesh. Hello, Dr. Shailesh.
Yes, sir. In place of Dr. Shailesh, myself, Amit Gurde.
And Sahaj Badeja.
Yes, sir.
Sahaj.
My name is Saj Parja. I am also here.
Okay. And Umangar.
Good afternoon, sir. So I am Akshita Pant. I would be presenting on his behalf.
Acha. And Umail RM. Hello.
Yeah, I'm
And
Umail,
who
sir.
is,
I am present here. Yeah.
okay, very good. And just we are waiting the session chair, Dr. Birendra Kumar. Dr. Birendra is here. Dr. Birendra. Hello, Dr. Birendra. So, dear, actually, can we do like that? We will meet at 2:30. Actually, some problem was that where. So, we all are requesting to just let me connect and talk to this when 2:30 will meet. Is okay?
Sir,
We'll start the session 2:30.
sir,
Hello?
there is a problem from my side.
हाँ सर आ जाइए हेलो हेलो
Yes, sir. You are audible.
या व्हाट इज द प्रॉब्लम विथ यू सर
Sir, actually, I have to go somewhere. Actually, I am working in a college and there is a exam. Exams are going on, and I have a duty from 2:15.
अच्छा अच्छा ओके आई विल टॉक टू यू लेटर because
Okay, sir.
externally required. So all other audience will meet at 2:30. Okay, sir. Hello. Hello, Shailesh, Sahaja, Umang, and
Yeah,
Umair.
okay, sir. Okay. Yeah, we
2:30
will
done.
meet at
2:30.
2:30. Yeah. Okay.
Okay, sir. But sir, will there be the same link which we are presenting right now, or another link will be shared to us?
Yes, sir. If there is an issue, then I can join at 4.
मेरा टाइमिंग दिया हुआ था 1:30 से कॉन्फ़िगर किया हुआ था दैट इज व्हाट द वेटिंग द होस्ट वेटिंग लिस्ट का महान है डॉक्टर साहब Okay, Mr. Ashish, I think you left. Yeah, Ashish ji. एक्सटर्नल का नंबर नहीं है डॉक्टर साहब है ना नंबर लिखा हुआ जीरो फोर हाँ, उससे अच्छा क्या होगा? दूसरी जगह पूछ लीजिए खाली। जनरली सर यही होता है। आप बिजी रहिएगा, हम लोग बैठे रहेंगे 5 मिनट। मेरा सुनो ना। बोलो सर। रिसर्च एडवाइजरी बोर्ड में नाम डाल दो ना। हेलो। डॉक्टर साहब नमस्कार। डॉक्टर साहब। हेलो। हेलो सर। करुण साहब। करुण जी, आपका मेरा एक्सटर्नल ज्वाइन नहीं हो पा रहा है, उनका नंबर गलत दिया। 9 डिजिट का ही नंबर है। डॉक्टर बिजनर जी। सेक्शन 8 का। नहीं नहीं नहीं। वो तो मैं बीच में 12:30 से था सेशन। तो 1:30 री लॉग इन था। कॉन्फ़िगरेशन गलत था। फिर उनसे कांटेक्ट कर रहा हूँ तो लग रहा है तो भी स्विच ऑफ आएंगे। तो अगर है तो दे दीजिए। ऐसे 2:30 को कोई कॉल नंबर है आपके पास? एक तो हाँ। हाँ, मैंने व्हाट्सएप पे मैंने दिया है। एक्चुअली क्या है ना, 12:30 सेशन था, लेकिन लॉग इन हुआ 1:30 को। ताकि वहां लगता कन्फिगर 1:30 को किया हुआ था। 1 घंटा तो हम लोग वेट करते रह गए। हाँ, श्योर श्योर।
वो भी वो भी बनाता नहीं आना रखो वो बगल में कहीं से रख दो।
हाँ, वो तो ये तो शुरू से भी है।
हाँ अच्छा ले लो फिर बेटा हो गया ना उसको
नहीं हुआ यार।
तो 2 घंटा बैठा के क्या किए
कहा था खामोश का बोला ही कमर
यही
में
तो है
लाइट है।
अरे रवि
डॉक्टर साहब भागो मत यार, काम कर लो, कंप्लीट तो कर लो डॉक्टर
हाँ
साहब।
भाई तो
वो कहाँ ले जा रहे हो?
तो
बुलाइए नहीं, यहाँ पर साथ में रहिए तब होगा। Hello, hello, dear students. Hello, dear presenter. Are you online?
Hello, sir.
Yeah. Who is
Yeah.
available? Sahaj,
Yes, sir.
you are in behalf of whom? Hello.
No, I am presenting my paper only. I am
Yeah,
presenting my paper only, malicious URL detection.
7 to 9, correct? Yeah, please go ahead.
Yes, sir.
Please go ahead. Please go ahead. Yeah.
Okay, so can I share my screen now?
Yeah, go ahead.
Okay, sir.
अजय सर, अरे यार कुछ करते नहीं है खाली।
Is my screen visible, sir? Hello. 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 Is my voice audible to everyone? Can anybody please confirm, is my voice audible here?
अजय सर, अजय सर, नेक्स्ट को कॉल करो, नेक्स्ट प्रेजेंटर को। सर नेक्स्ट प्रेजेंटर को कॉल कर लो। ये आवाज नहीं आ रही है। आप, अरे म्यूट है दादा, म्यूट है। अजय सर आप म्यूट हैं। हाँ अब अनम्यूट हुए। कितने लोग हो गए सर आपकी में?
Please go ahead.
अजय सर कंटिन्यू कराओ।
Yes, sir. Please go ahead.
सर आप कॉल करो, सर कॉल करो। आपको लिस्ट है ना, प्रेजेंटर को कॉल करिए। कॉल का मतलब पेपर आईडी आपके पास है, पेपर आईडी का उन्हें बुला लो।
Yeah, no, I have told that Sahaj, please, Sahaj, go ahead. Sahaj.
Yes, yes, sir. Okay, okay. I am
Yeah, I'm
presenting. I
hearing
was
you.
just
Please.
confirming whether my voice was
Yeah, you
whether
are
my
audible.
voice was audible to
Yes,
everybody or
audible.
not.
It is audible.
You are
Okay,
audible.
okay,
Continue
sir.
please. शंकर सर आप कंटिन्यू करो इसको ना पूरे सेशन।
Okay, sir. Just a minute. Sir, I am sharing my screen. Is it fine now?
Yeah, fine.
Do full screen. Yeah.
Is my screen visible now?
Yeah, visible.
Yes. So I am, first of all, I am very thankful on the that I have been given this opportunity to present my paper on behalf of my whole team. And our research area is cybersecurity and data mining base, where we have done this malicious URL detection using data mining techniques. Uh, my main motive for doing this research is I had been scammed in this part of the field in my early teenagers, and I have lost ample amount of money in this. So, uh, being a part of a CS student, I am very glad that I have been able to make the research work on this domain. So, this is the outline of my whole presentation. I would be discussing what are the malicious URLs, which are the existing solution before we have done our approaches, which are problem faced in the solutions which were available, our methodology and results and discussions. So basically malicious URL is the URL from which any part of the execution can be exploited. If it is a banking website and if anybody creates the dummy website for the same, then the second dummy website would be considered as a malicious URL, as it is not a legitimate website. So it is very tough. It is very hard to manage all these website, as everybody is turning to over the internet, as everybody is shifting towards the internet and making their URLs and making everything their businesses, their representations online. So the methods which are available right now were mostly ML based, and no one was looking for the deep learning approaches over it. Even the better forms of RNN could be used in this approach, which I have not seen anybody using over it. So we have tried using it. The existing solution majorly focuses on the blacklisted websites, which are generally the cybersecurity teams, which just make the whole URLs which have been blacklisted and try to remove it by reporting it to the higher authorities or search engine owners. Signature based URL is only those candidates will be available to access that URL who would be having certified tokens over it. Content-based URL checks whether the content inside the website, considering its text, its images, its videos, HTML code, or another Next.js, various codes are being used inside it, whether they are suitable for certain systems or not. URL based classification is basic breakdown of domains, subdomains of the URL link to find out whether they are harmful for the regular usage or not. And feature based engineering is the best approach for it, which analyzes the whole URL and the content inside it in various forms by breaking down it step by step. So the problem with the existing approach is the amount of resources available at a particular time is very low, as URLs are being increasing day by day. Many people are using the various types of domains by buying it from different sites and making the URLs in a public. So it is easy for the hackers to publish the different types of execution channels and try to overcome the loopholes of the website and make it. The research gap where we find that we can play a role was the deep learning approach, which was missing from the existing solution, and most of the people were using only machine learning approach, as I have mentioned over here. We have basically focused on CNN and ANN techniques in order to overcome all of this. The methodology which we propose is we initially collected the whole data from various parts, which I have mentioned over here. These are the various international websites from which you can take the malicious URL collected websites, and you can try to find out the few of them which are not malicious and classify the data, whether the given URL is blacklisted or not, or whether the given URL is particularly malicious or not. So I have totally collected 6,50,000 around links in order to train all my data set over it and try to give the results. So our step in feature engineering is we have analyzed the whole URL in the basis of the listed fields which I have given over here. Having an IP address classifies that check if the URL contains an IP address instead of a domain name, which can be signed by a phishing site. Abnormal URL means the detects if the URL has a typical structure that does not conform to the URL standard patterns. Google Index will be checking that whether any of the particular website has been listed in the indexes of the Googles. Similarly, for count of dots, the number of periods in the URL will be classified, and a high number can be indicated as a complex subdomain structures. Similarly, we have done the analysis of different other names which I have mentioned over here and classified and trained our models over it. We have done pre-processing by label encoding various methods so that everything could be perfectly generalized, and we have split our data set in such a way that we use scaffold methods in order to have the best approaches and best results for all of the executions. These are few machine learning models also which we have tried in our execution so that we can get the results of machine learning models so that we can compare it to deep learning models also, as we have more confidence over the deep learning models. Here is the whole output of our machine learning approaches and deep learning approaches. I have mentioned the average of both the approaches. We can clearly see that the deep learning approaches is giving us 95% of accuracy, while machine learning is only giving 85. And here the best accuracy is given by LSTM RNN, which I also previously mentioned that deep learning RNN and CNN techniques are giving best solutions over here. So this is the conclusion of all of our paperwork, that our models are giving best accuracies, and in machine learning we have been opted with the 96%, while in deep learning we have opted with 96.58% of the accuracies over here, and average is also mentioned over here. But as this is a growing field, everybody is shifting towards the online mode. The number of URLs will be getting overloaded in the near future only, considering the scenario of Industry 4.0. Even considering the shift towards Industry 5.0, we need to make the whole structure to be a blockchain based, or the whole structure would be considering the execution of Next.js and Web 3.0 technology, so that most of the execution would be on the server base rather than being on a client base, so that no tunneling, no phishing, no scamming could be possible because of all of this. We have given that our accuracy is around 95% overall, but this could be a variation as the number of malicious URLs are getting on increasing, and overall techniques which any of the artificial intelligent person or cybersecurity person has been using right now could be increasing and could be further studied even more. These are few of the references which we have used in order to get every of the portion to understand how to work, how to analyze, how to check whether all of this is working or not, and all. Thank you. This is from my side.
Dr. Rajiv, are you online? Dr.
Sir,
Rajiv?
sir, ask some
Yes.
questions. Please ask some questions.
Yeah,
Yes.
I think Ajit, Dr. Rajiv
Yes.
is, I think, our external.
Yes. Am I audible, sir?
Yeah, very audible. Yeah.
Okay.
Yes, sir.
So,
Yes, sir. You are audible, sir.
yeah, Dr.
Yeah,
Sahaj,
please,
uh,
we have been got some delay.
the
anyhow.
question,
Please,
I
any
would
question,
like to-
Dr. Rajiv?
yes, the first question I would like to ask you is, what exactly is the novelty? So since you are comparing a lot of methods, or you can say the machine learning and deep learning models,
Yes,
which are
sir.
already existing in the domain, right? So what exactly do you think is the
Yes, sir.
contribution?
Machine learning models were our
No, I
major
am saying
contribution is
yes, yes.
is in. Yes, sir. Our major contribution is mainly two parts. One is pre-processing, where we are doing a lot of feature engineering in order to extract the particular extent of every details which link can provide us in order to channelize whether it could be considered malicious or not. And similarly, giving the whole URL not completely to the machine learning model, but by breaking it into a token and using the refined version of RNN, which is LSTM, so that we can get the better accuracy and better executions over it. So the existing solution would be, which we have analyzed, that they were providing around 80 to 85% accuracy even using deep learning models. Well, we have refined it and tried it to make it around 95% by using our data set, which I have shown to you in my presentation.
Okay, I got it, but I am wondering how RNN is basically helping you out in getting the better accuracy. Since the link is going to be of a
Yes, sir.
limited size,
So
second thing, I feel that there is no interconnection or interlinkage between the tokens in the link, right? These are going to provide you some kind of individual, or you can say the separate details. So how RNN is actually helping you out?
yes, sir. So basically, we can use the encoding methods which LSTM provides. Is there is a certain specification of a URL which makes it validate, or the content inside it to be a validate. We have a lot of malicious URLs which we compare that if such things are present in any particular kind of the URL, then for that particular purpose we will declare it to be a malicious one, else we will declare that no, this URL is safe to measure.
But still, I am not getting how RNN is helping you out. It can be basically helpful in any other machine learning model as well.
Okay, sir, just a minute. Let me share my screen again so that I can try to make my point clear.
Okay, good.
Yes. Is my screen
Yeah,
visible,
visible.
sir?
Yeah, visible.
Yes, sir. So here, basically URL can be break down in this many of the parts. Okay. So we will count every single part and give every single detail separately to the RNN rather than giving it as a whole. So if there would be a slightest criteria of considering it, then also we can get the output that means the particular URL is not safe, or it has been flooded, or it has been for a privacy purpose. So this would be our approach.
Okay, Doctor. Thank you. That's all from my
Is it
side.
okay, I think. Thank you. Thank you, Saj. Thank you very much. Really. So,
Thank you,
shall we go
sir.
for next?
So can I
Dr.
stop presenting now, sir?
Yeah. Next is Dr. Shailesh is here. Hello, Dr. Shailesh.
Sorry to interrupt again, sir, but can I leave now, or
Yes, go ahead.
are there any other formalities we need to complete?
No, leave.
Okay,
leave.
okay. You can leave. You can.
Please leave.
Okay. Okay. Thank you, sir.
Now, Dr. Shailesh Kedia, who is on behalf of Dr. Shailesh Kedia is going to present. Anyone? Okay, Umangal. Umangal is here. Oh,
Sir,
ma'am.
this is Akshita Pant. I would be presenting on his behalf today.
No, what's your good name, ma'am?
Sir, I'm Akshita Pant.
Not showing name, anything. Akshita Pant. You are co-author here?
Yes, sir.
Okay, please go ahead. Yes.
Sir, I would be sharing my screen.
The paper number is 739,
Yes,
detection
sir.
and classification of IoT malware from the MQTT dataset.
Yes,
Yeah.
sir. Sir, is my
Dr.
screen
Rajiv?
visible? Sir, is my screen
Yes, sir.
visible?
Yeah, please go ahead.
Okay. Good afternoon, everyone. My name is Akshita Pant, one of the authors of the paper Detection and Classification of IoT Malware from the MQTT dataset. So these are the various topics that would be covered in my presentation today. Talking about the paper, we have IoT, that is Internet of Things, which has transformed the world of physical objects by incorporating internet connectivity, data processing, and analytics. We have MQTT, that is Message Queuing Telemetry Transport. It is a communication standard developed by the OSS group, and it facilitates machine-to-machine communication. Its advantages include its scalability, reliability, security in its implementation. So basically, it follows the publish-subscribe mechanism in which there's a message broker that separates the publisher from the subscriber and allows the communication between them. So the diverse and numerous IoT devices that are vulnerable to cyber threats is a serious problem nowadays. So absence of a standardized and integrated mechanism exposes the IoT infrastructure from the various attacks that take place that include malware and the viruses. So our paper objectives include to implement the machine learning and deep learning algorithms for malware detection and calculating the accuracy, F1 score, and confusion matrix for each technique so as to provide a comparative study for choosing which is the most effective method. Talking about the existing works that have been done, so MQTT has recently been a subject of research for the various researchers. Researchers in the paper of algorithm for detecting and classifying MQTT protocol and IoT attacks have used techniques like KNN, CNN, LSTM to detect the MQTT protocols and IoT incursions. Researchers for malware detection and IoT introduced a deep learning classification model. They had a three-step approach, including pre-processing, ensemble, classify using outputs from CNN and LSTM. And there are many more papers that have been worked so far. But there are problems that have been there in the existing paper and might arise in the future as well, since the IoT industry is increasing day by day. The advancement of IoT sector is leading to the complexities of the gadget, which is also increasing the threat for the attacks that might take place in another level, for which we need to improve the current malware detection mechanism. So now we would be coming to the proposed model. The first step for the first step we had is the data collection. So the on the right hand side, we can see the entire flow chart that highlights the procedure. So the first step is data collection. The MQTT dataset was downloaded from a GitHub repository, which composed of the IoT sensors that used MQTT, where each element had a from the real network had approx 8 sensors. The MQTT broker was built with the Eclipse Mosquito. The setting was of a smart home which gathered data on light, temperature, CO levels, humidity, smoke, dose status motions, and the fan operations. And it had 5 malwares, namely brute force, DOS, flood, malformed, and slow IT. The next step is the pre-processing. The data processing is done for purification, and it includes 3 steps like data cleaning, data transformation, and data reduction. Data cleaning means removing of the unwanted and irrelevant data that can affect the performance of a model. Besides that, data transformation converts the data into more suitable format. Data reduction and feature extraction involves reducing of the dimension of the data set, which can help in the detection of the IoT malware. All this is done to reduce the complexity of the data so as to implement the model more efficiently. The first model is the CNN. CNN stands for Convolution Neural Network, as it has been mentioned. It is a deep learning technique that consists of an output layer, several hidden layers, and an input layer. Convolution layer and the pooling layers and the non-activation function make up the hidden layers, as it has been depicted in the picture. The convolution layer apply a set of filters to identify particular characteristics in the data. Our model is made up of a 2D convolution layer, a flattened layer, and max pooling for the dimension reduction. It starts with a dense layer with a dropout to prevent overfitting. A maximum of 200 epochs were used in the training with a batch size of 1000. The second model is the random forest, which is a supervised and ensemble learning model that uses various decision trees, and the outcome is predicted using forecast from each of the decision tree. It requires very less time, and it is extremely accurate for predictions, even for the large data sets. It is divided into two states. The first include the making of the random forest using the various decision trees, and the second step includes the creating the predictions from the trees that have been that have contributed in this forest. Then the classifier uses several arguments like the criterion, max features, and estimators, jobs. The third model is the gradient boosting, which is an ML model that integrates less powerful models to form a robust predictive system. It starts with a simple model like a tiny decision tree. It learns from it and makes mistakes. Then it adds another smaller models and focuses on the mistake that it had previously made. The process keeps repeating with each model, learning from the errors of the previous one, so as to make very highly accurate outcome in the model. The next model is the light gradient boost model. Light, the prefix itself tells how fast it is. So light gradient boost, it employs a tree-based learning application, and it has a quick speed as compared to the other gradient boost models. And it can also work on large amount of data. The emphasis on exact results placed in light GPM is another factor for our model. It has been chosen. So the model is trained on the light GPM model. The fit method is used to maximize the loss function here and adjust the hyperparameters to optimize the performance of the model. The last model we chose was the naive-based model, and it is quite good for classifying tasks, and the strong independent assumptions between the various characteristics and the Bayes theorem of probability forms the foundation of this model. This model is quite good and simple to use, but it has a significant drawback that like it needs these so-called independent predictors for the working of this naive Bayes. And if I talk about the results, the model proposed in this paper were trained and tested to detect the malware and classify the malicious traffic into 6 classes: DOS, brute force, flood, legitimate, malformed, and slow ITE. So all these models were compared on the basis of how correct or how accurate they were, that is accuracy, their F1 score, and the confusion matrices. So the table for the accuracy and F1 score has also been attached here. So we can see from the table that all the ML models have attained the accuracy level above 80%. Except for this naive Bayes, which has an accuracy of 78% and F1 score of 75%. But based on our confusion matrix, we came to know that naive Bayes was best for classifying the legitimate traffic. LGPM and random forest almost have the same accuracy, as we can see from the table that it is 90.3 and it is 90.5, and also the F1 score is approximately similar, 90.0 and 90.2, but random forest outperforms by having slightly more values of accuracy and F1 score. It was also observed that malformed data and flood attacks are difficult to distinguish from other attacks, as they were generally falling into other categories. So the random forest, based on the accuracy F1 score in both training and testing timeframes, produce the highest accuracy and F1 score. To conclude, I would say that to protect the data from cyber attacks and malware, it is important to differentiate between all these malicious data, and the different models that were compared, that were used, were compared based on their accuracy, F1 score, and confusion matrix, where a random forest technique proved to be the most effective with the greatest accuracy percentage and F1 score. Even if there is a lot of work that is currently being done, there's a lot that can be done in future as well. Like people, like the researchers in the future can combine two deep learning algorithms that would force on developing and get development of IoT and MQTTs to give efficient and accurate algorithms. New methods for isolating and categorizing IoT malware can be developed by the researchers. These were the references for the today's different presentation, and that's all from my side. Thank you.
Oh, great. Dr. Arun is here. Dr. Arun,
Ji, I am here.
yeah.
Go to your
great.
first slide.
Okay, sir.
Actually, go to your first slide. I joined late. Go to the first slide. Yes. Okay. Actually, you have implemented 4 or 5 basic machine learning models.
Yes,
Okay.
sir. Yes, sir.
First time, for most thing, you have not given any single line, region of selection of these models. Why you have selected these models?
Okay, so we the basic objective of our paper was to implement different types of like models, not just similar types of, but different types. Like we implemented the deep learning models as well, like the CNN, and we implemented the ensemble learning models like the random forest, and we were into machine learning and deep learning as well. So what we were trying to do is comparing how accurate a particular type of model can be for a particular problem. Say, in the if I talk about their accuracy, were almost the similar. Like CNN is yes, sir.
There is always there is a region of selection of every model. Machine learning, if you know the now machine learnings are stable till now, why we are going to evaluating on machine learning models? What is the reason? If deep learning models performing better, they use automatic to the better results. Point number 1. Point number 2, you are telling we are using again, you are not giving the answer of region of selection of models. Always selection of models will be based on the types of data set.
So we had a supervised data set. It was labeled and as in the output.
How many classes in your data set?
5, sir.
5 classes.
Yes, sir.
Then what are the region you have select? Select the naive Bayes model.
So actually, like naive Bayes is based on like the probability. Just a second, sir. So can you please repeat the question?
Again, I know. Okay, no issue. Go to the result section. Yes. You can say at how many decimal places we have to write the accuracy.
So
this is how many decimal places? Is it right way to write the accuracy?
So 6 approximately to up to 6 decimal places can be fine.
Is it correct way?
So
at least we have maximum 4 places. Now where is this data set is public data set?
So this data set is MQTT data set. It is a public data set.
How have you given comparison with other researchers? Somehow other persons work on same data set? What is their accuracy?
The accuracy was approximately similar, but
How we
like
can
our
say?
random forest,
How we
uh,
can say? Have you given any comparative table?
no, sir.
Then
But sir, we mentioned it like,
in your statement you have written told, not written. Neobase has the best accuracy, best performance, but its accuracy is 78.
no, sir, I did not say it has the best accuracy. I said it has the least accuracy out of all these.
Accuracy. Why first model has given only 90%?
Oh, sir, sorry.
Why LG BM have given 90% only, not more than that?
So all the accuracy and F1 score, basically they depend on what type of data we have and how the data has
Okay,
been
okay,
processed.
ठीक है. Go to the first slide. I want to note down your details. ठीक है. End of my side, sir. Sir, I end up from my side. You go it from other chairs if you can ask the question.
हाँ सर.
Akshita, I have a question.
ये चलेगा वो तो कोई
Yes,
आएगा.
sir.
Whenever we
हमने
do
कॉल कर लिया.
research
ये
or
करा
try
तो
to publish a
हाँ
paper,
लॉक कर. हाँ
we
लॉक कर.
usually go by comparing the existing research with our research, so that we can show that
हाँ.
yes, we have contributed something to the society, right? Or something to the research domain.
ठीक है चलेगा.
But what you have done, you have picked up the data set, you have applied the already existing models on the data set to just get the accuracy. So it does not look like that you have done a kind of research work, but it looks like a project only, like BTech project. So
Sir,
the better way to do or better way to publish a research work is to define what exact contribution you have given by comparing the results with the existing methods, right?
sorry, sir,
So,
I
but
did not mention it today, but our accuracy and our outputs have been are as compared we had the existing results and we tried to improve the result, and on this
no,
on some level.
what are the what are the existing results on which model?
फोन कर दिया.
So the random forest and
No,
CNN model.
Akshita, the problem is random forest is already an existing model, right? What you are doing, you are
Yes,
just
sir.
picking, you are just picking that, applying on your data set. This does not make your project novel. You can't claim that you have done this.
Okay,
To
so I keep
contribute,
this in mind.
yes, to contribute, you need to find out a way by which you can provide a kind of novelty to the work, right?
Sure,
If
sir.
there are existing works and you are just synthesizing them to give a better result, it does not give the novelty. There should be non-obviousness in the nature, so that your work can be regarded as a research work, right?
Yes, sir.
Okay, that's all from my side.
Okay, a lot of queries. And shall we go ahead, Professor? Doctor, for next?
Yes, sir.
Yeah, very good. Thank you, Akshita.
Thank you, sir.
And I think a lot of suggestion is given to you. And
Yes, I'll
you
surely keep them in
also-
mind and improve for the next time.
Oh, great. This is our aim. Next is the Dr. Shailesh Kedia. Anyone is on his behalf?
Yes, sir. This is Amit Gurde. In place of
Welcome.
Dr. Shailesh Kedia.
Yes, Amit.
Can I share my screen?
Yes, sir. Please go ahead.
So good afternoon to all of you. The paper title is Machine Learning Algorithms for Unbalanced Data Set, Promotion Prediction for Employees. So myself, Amit Gurde, I'm presenting this presentation and my paper ID is 726. So this is the outline of the presentation.
Yes.
Coming to
Go ahead.
Coming to the introduction, properly executed promotions boost the company's success, motivation, and loyalty. Transparent and objective promotion criteria are the essential for effective career management. Promotions enhance the worker productivity, motivation, and job satisfaction, benefiting the employees and the company. Codifying the promotion policies is recommended for improved employee performance and organizational output. A decision support system using the data analysis helps to identify potential promotion candidates and improves the KPI in promoted roles. Talking about the machine learning automates the learning strategies with data and computational models in artificial intelligence. Supervised learning uses labeled data sets, while unsupervised learning operates without predefined solutions. Supervised learning is used for the real-world tasks like spam categorization, whereas unsupervised learning is beneficial for tasks like customer segmentation and pattern recognition. In employee promotion, supervised machine learning models include the logistic regression, naive Bayes, k nearest neighbor for classification and regression. It uses the multiple decision trees that work independently and combine their predictions. Support vector machines are used in recommender systems, but are not probabilistic binary linear classifiers. Predicting employee promotion dates is crucial for boosting the morale and productivity. Class imbalances is the dataset can challenge standard machine learning algorithms in making accurate prediction. And challenges of the unbalanced dataset in promotion prediction. Class imbalance in promotion prediction datasets hinders model performance by favoring the majority class. Skewed data from class imbalance makes it difficult for models to capture subtle patterns. Traditional accuracy is inadequate for unbalanced datasets like precision, recall, F1 score, ROC, AUC, and PR AUC are more relevant evaluation metrics. So to address class imbalance, theoretical approaches include resampling techniques and cost-sensitive learning. Resampling involves the oversampling, undersampling, and synthetic data generation, while the cost-sensitive learning assigns different misclassification costs to optimize the algorithm. So, talking about the result and discussion, employee promotions are influenced by various factors like key performance indicator, that is KPI, then tenure and courses taken. A logistic regression model with 95% accuracy and 82% precision has been developed to predict the employee promotions. So this predictive model can assist HR in planning the promotions of the employees, aiding in the transition of employees into new roles. Data visualization helps HR identify patterns and store knowledge for future use. The research aims to enhance promotion prediction analysis by incorporating the additional relevant characteristic for improved precision. Coming to the conclusion and future work, so predicting employee promotion is crucial for human capital development, and 3 machine learning methods were developed and compared for this purpose. So actual company data was used to build and analyze a training data set for quantitative analysis. The study tested common supervised machine learning techniques, which all demonstrated the ability to make accurate predictions. So specialized software was created to test models on new data for anticipating employee promotions. The research emphasizes the importance of predictive prediction models for employee promotions in the workforce. And these are the references considered for this. Thank you.
So, Amit, go to first slide.
Yes, sir.
Please go to your first slide.
First slide.
Amit, I think you have given very brief in discussion about the implementation of your work. You told about the implementation of the HR policies of promotions, but you have
Yes.
not discussed about the features which we have taken to identify the promotion policies. On which basis you have decided, does this model is generalized for every company or specific companies?
Some parameters regarding means on which parameters it can be implemented, that is mentioned in one of the slide. Like the KPI is one of the factor. Then which are the courses taught? These are some of the factors on which that can be implemented.
Can be implemented, yeah, you can implement, you are implement, have implemented.
Sorry.
What are the features you have taken to implement this policy? Have you implemented this process? You have told that 95% of accuracy of random forest. Again, I am telling why I use random forest.
That is based on the means the type of details which
Yes.
has been collected.
Why you have selected the random forest method model? What is the criteria of selection of model?
That is not mentioned here.
Yes. This is critical part. Na? We have to know the every region of every selection, na? Working of every. I have told 95% of accuracy of random forest. Why not 98? And what is the reason behind that? What is the problem in the data set which we have not incorporated, implemented, increase the accuracy 98%? I think limitation we should discuss. That is the core part of the research.
Yes, sir.
No?
Yes,
This
sir.
should, and again, third point again, this is the gap you have. Is it this public data set?
Yes, sir. This is public data set.
Then again, we have not shown any comparison of previous work.
Okay.
We should. I think this is just like this presentation. Not I want to say some hard work. Word. This is just like only simple formality. I think Anuji. Nothing as I found in this paper. Everything is hidden. I think you want to hide everything. Either it's something hidden for. I have not learned anything from this content.
Amit sir.
Okay,
Yes, sir.
from my side.
Yeah, actually, you have to increase your data set and lot of other factors you have considered also. Yeah. चलो ठीक है. Some more session, Dr. Arun. I think you're assistant professor there.
ठीक उसमें कोई रिमार्क में वही मैंने तो प्रश्न लिख दिया था
Dr. Rajiv.
और लास्ट में वही एब्सेंट करके मैंने फोन किया
Yes, sir.
इंटरेस्टेड
Any question, any query, any session, please?
Yes, Dr. Amit.
Yes, sir.
So your problem is for the unbalanced data set. So what do you mean by unbalanced data set?
Means the data set based on which is not is at the same level.
No, Dr. Amit. I think you were not well prepared for the presentation. I'm sorry to say, but
Yeah, I have noted. I have written on the court comments report what the session given by Dr. Arun and Rajiv.
yes.
Yeah, noted. And
Sir, we can move to the next candidate then.
Yeah. Next, please, Umail RM, that paper ID 741.
Hi, sir. Good afternoon. Yeah, I'm Umayal. Can you hear me, sir?
Yeah. Yes, Umail, please go
Sir?
ahead.
Yeah, good afternoon. Yeah, I'm going to present about the topic called The remaining useful life prediction of lithium-ion batteries using the electric vehicle battery management system. And then from the introduction, I want to explain about the introduction.
Share your presentation. Share your presentation.
Sorry.
Share your presentation. Your presentation is not visible.
Oh, sorry. One minute. Yeah, my topic is remaining useful life prediction of lithium-ion batteries in electric vehicle battery management system. First of all, I want to explain about the outline. In the importance of EV.
Go to the full slide, full slide mode. Write it on full slide mode.
Just a minute.
ये राइट हैंड साइड पे देखिए एक कप की तरह बना, उस पर क्लिक करिए राइट हैंड साइड पे। अब देखिए नीचे और हाँ ठीक है, हाँ क्लिक करिए और नीचे वो वही नीचे 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 आइए, नीचे करिए क्लिक।
1 minute.
F5 प्रेस कर दीजिए अपने लैपटॉप या उससे।
Shall I start?
F5 प्रेस करिए, F5।
Okay.
F5 की प्रेस करिए।
Where is it, sir? Yeah.
F5 अपने कीबोर्ड पे F5 प्रेस करिए कि F5।
I pressed. Yeah, I pressed. Yeah. Okay. Now I can.
What is your paper ID?
741, sir.
Oh.
Yeah. Now I'm going to present the paper. First, the introduction part, the importance of EVs and lithium-ion batteries. EVs are the nowadays most of the people using the electric vehicles. For that, we use lithium-ion batteries are the most important things, because the carbon emissions are there in using the fuels or petrols or something else. Lithium-ion batteries help to reduce that, and also it is more reliable and perform well in the current situations. It is an essential aspect of battery management, is accurately predicting the remaining useful life of lithium-ion batteries. And then the RUL prediction plays a critical role in optimizing battery utilization, improving safety, and reducing maintenance cost. It is very useful in future. Nowadays, most of them are using nowadays. Charging stations are there in everywhere, so this electric vehicles are most useful for everyone. And also it is first I'm going to predict that RUL in lithium-ion batteries is from the machine learning process by use lithium-ion batteries is a complex task to intricate interplay of multiple degradation mechanisms like capacity fade, aging, increased internal resistance. If you increase the internal resistance, the battery capacity will battery cycle will reduce. That's the thing here I'm going to explain. And then the degradation process are affected by multiple factors such as temperature, charging discharge profiles, and operating conditions unique to EVs. I'm using actually data-driven approaches only I used here. My data my problem statement is that lithium-ion battery electric vehicle battery management, how it predicts the remaining useful life. That's the thing I'm using. I'm predicting here. From the battery RUL refers to the cycles required to the maximum available capacity degrade to the specified threshold. The threshold charging and discharging rules are the most important things here. My data set is structured data set. So this is the data consistent of 12 variables: internal resistance, quick charge, quick discharge, temperature in average, minimum and maximum, and then cycle, and then cell type, cycle life. And then this one is the C1 and C2. C1 expresses that hour ampere per hour capacity. How 1 hour it will take 1 hour, or it will take half an hour. That kind of capacity it will take. That C1 and C2 will take the voltage as C1, C2. And Q1 is the state of charge. It helps to identify. It helps to inform us to. It helps inform us to indicate the final battery time. It is very useful for us. It is the health of the battery. And then I took actually the 1,10,312 values here, and then 12 columns or 12 variables. I took 12 variables, and then I analyzed the univariate analysis. Here the affecting part is the temperature, state of charge, charging and discharging rates, depth of discharge, number of cycles. These are the main affecting factor for the batteries. C rates, I already explained that C rate, that is the 0.5, commonly rated as 1 C. 1 C as the 1 ampere per hour it will take. And then 0.5 C contains the 500 minutes per hour. And then 2 C is it delivers the 30 minutes per hour, 30 minutes ampere hour. And then I predict RUL by using the by finding the 3 methods, but data-driven method is the most relevant method I chose here. And then for EDA process, what I did is there is no missing value here. So next step, I removed the internal resistance less than 0. Some very rare values are in the 0 values. So I removed that internal resistance less than 0 values. And then in the I used 2 methods: regression model method and the classification method. In the linear regression method, in the regression method, I used regression model and the random forest model. And in the classification model, I used 3 methods: logistic regression methods, random forest. Here also I used random forest classifiers. And then support vector machines, that also I used here. And then next step, I removed the outliers in the classification method. And then we took the first we took the 100 cycle from the data for the regression model, and first 20 cycles for the classification model. By using statistical analysis, some more methods we used: univariate method, bivariate method, and multivariate method I used. In that, from that I found that mean and median are equal for most of the features. So it is normal. So it may normally distributed here. These are the maximum values of that each variable. And then bivariate analysis, I used the linear regression method. In that, I use the Q1 and cycle life. That Q1 is the state of charge that indicates that 80% is the maximum percentage here. Above that, it will stop. It is the indicator for us to again we charge the battery. So the mostly 0 to 100% is the actual value for the state of charge. But 80%, if in this way data we have a 80% indicator here is for everything here for all variable is 80% is there. And then multivariate analysis, I use the correlation map, heat map. Here I found that the cycle life is related to that Q1. Most of that are positive values. So Q1, C1, and QC, the quick charge and quick discharge, all have the positive correlation. And then temperature also temperature, the three temperatures are all mostly correlated, interrelated with each other. And then quick charge and quick discharge here, that also the positive, it is also positively correlated. We can find that we can separate, we can found the in future we can do this separate analysis we can do. But I did here complete I took complete data here. And then regression here I found then I split the data into train and test data. Train data is 70 is to 30 I took here. And then using the I trained the data into the training model and predicting in the testing model. And then here I used the regression analysis, linear regression model. And in that I got the actual value is somewhat late, actual value is not that much best in the prediction value, because we got the error as 0.5. We got the accurate score as 0.54, and then error is too much, much bigger error here. So it's not that much good fit. So it's not significant here. I create the random forest for that. Random forest it's an ensemble model. It will aggregate the trees in so it will give the somewhat better result, I thought. So I use this model. In this model you can find this actual value and prediction value are both are in the same nearly the same points. We can see the score as 99%. And then the error is also reduced here. And this I feel this is a good fit for this data. And then the classification algorithm, I took the less than 20 cycles. And then we need for that I choose that 700 is the middle point as less than or equal to, that is the less than 700 is 0 and greater than 700 is 1. That type of that type I classified here. In that graph, yeah. In sorry, this data, the graph is missing. Yeah. In this random forest classification, got the better result. I used the logistic regression model and the random forest regression, random forest classification model. In that logistic regression, I got the 0.99%. Yeah, I got logistic regression model. I got the 0.96 accuracy here. By using the confusion matrix that there I got this 0.96 accuracy, and then the random forest classification model I got the accuracy as 1. So this is the better fit. In the SVM also it's a 0.99 I got. The overall whole data, it's a good data. We can predict it predict it in the classification model and regression model is the best. We got the best accuracy here, and then a final conclusion. This result of this work is actually that the fast charging of lithium-ion batteries. That is the data. Actually, I took that from the GitHub. So that data set are charged. That one-step fast charging at C1, Q1, C2. That and all I analyzed in the data separately. That cutoff potential, there I got the upper cutoff potential and lower cutoff potential. From the data I got 2.0 voltage in the C1, and the lower cutoff value is 3.6 upper cutoff value is 3.6 voltage here. And then that and all I explained here. So in future we can predict the electric vehicle battery management system. It is more reliable and performing good performance, and then the lifespan of lithium-ion batteries also will give a better result here. So we can use this data for future more. Some more we can analyze it from the discharging part, and the temperature part we can analyze it from that. That's all of this.
Okay, I think out of these four, one of the good presentation I have given the better way, something better way for analysis of the data set. One or two small questions.
Yeah, Dr.
Yes.
Please.
One or two questions from my side. Now, I think have you done any comparative analysis or not?
What's that?
Comparative analysis of the data set. I think it is public data. Have you done this work?
I analyzed separately, but I took that from the data. Some of that the results are there. Completely, I not took that fully.
Okay. Bivariate
analysis and all I did separately, and then that some more I added here.
Miss, you have done some amendment in the data set?
No, amendment I didn't do anything. I took the same data I took. That analysis part I analyzed separately from that.
Okay. Then someone else also have done same work for the identification of accuracy of charging of these lithium batteries.
Who, sir?
Some other researchers did some other researchers
No,
also.
me and Aditya both are same team. We both only did that.
I am asking, rather than this research, some other researchers also have done this work or not?
Maybe they did. I don't know. Actually, I took only the data. That's all. Yeah.
This part is missing. Actually, you have told that 90 given the data at 96 accuracy at some point and 99% of accuracy at some point.
Where's that?
I think you have claimed that the accuracy was at some point at 96. Some models and some models at I think 99. If I am right.
Yeah, this one logistic regression model. Yeah, here 9.96. Yeah.
9.99. No. So I think if this is it clear, correct that this disease accuracy is 99. I think it may or may not be. I mean, correctly overfit the
99
data.
is the correct accuracy, sir.
Now, how you can say this is correct? Have you checked the
Sir?
evaluation matrix?
Sir,
Confusion
what?
matrix? Have you checked the confusion matrix?
Yeah, you
Have you
can
checked
check.
the
You
confusion
can check
matrix?
it. Yeah, you can check it. Just a minute, sir. I will share that screen. One minute.
Okay, it's okay, Umrao, na? Yeah, it's okay. If you're not getting it, okay, it's
Yeah,
fine.
I can. Yeah, just it's the last.
No issue. No, it's go to the presentation, and
Okay.
I think it's one of the good presentation. It's fine from my side.
Okay. Thank you. Anything else, sir?
I think we are getting late here. We should go. Dr. Rajiv, any question?
No, sir. We can move.
Actually, last question, yeah, from my side. What lifetime you have considered for this lithium-ion battery? What is 20 years, 30 years? What is the lifetime? So we can.
Actually, maybe 15 to 20 years. I read many data, actually, many things, many research in that 15 to 20 years is the maximum, I think.
Okay, thank you. Thanks for. Actually, sir, there are 4 candidate that paper ID is 726, 729, 739, and 741. Now presented at 1 candidate that's 718. Ashish Vishnu, he presented earlier. So all 5 has attended online. Dr. Arun and Dr. Rajiv. So shall we close or shall we wait that people also? Once I questioned him, Ashish Vishnu, that when the external income also please comes and show your face. What to do? 4 people actually here. 4 candidate now presented 1 he did earlier. So I have signed for all 5. So thanks, Dr. Arun, and for your that availability, and Dr. Rajiv, and we are very grateful to you that you have attended and as a session chair external, second IEEE International Conference on Communication Security Artificial Intelligence today, and we hope that in future we will meet again. And thanks from Galguria side that
Thank you very much.
really it was a great session, and I think we will evaluate the candidate, and of course all the points I have noted what they have suggested in the comments box, and we hope that candidate will also improve himself. Anyway, a few words.
Thank you, sir. Thank you, sir.
So thank you, sir. Thanks for giving me the opportunity, sir. Thank you, sir.
Yeah, few words from your
Shall
side.
I leave, sir?
Just wait 2 minutes.
No,
Dr.
sir.
Arun, few words from you.
It was a nice experience, especially the last presentation was very good. I think some of the persons were doing some actual research, and in this type of conferences require actual research. Actually, they are not doing some serious in some of them, but some of good researchers motivate some others to work in like that. It will help to others to work in the right direction and good way. It's got nice experience and good for us. I hope we will meet in future very soon. Okay, thank you very much.
Thank you, sir. Thank you.
Dr. Rajiv, for any few first, any comments from your side, please?
Yes, sir. Thank you. First of all, thank you for having me to chair this session. And I think the presentations were good. And it is always nice to interact with the young researchers who are actually doing the research in current scenario. So always nice to hear them and at this kind of platform. And happy to share that I fully enjoyed this session and learned a lot. So thank you for having me again. Thank you all.
Thank you. Okay, sir. Thank you. Thank you very much. But anyhow, I'll wait till 4 o'clock. Maybe that gentleman will come again. She's Vishnu. Thank you, Dr. Arun. Thank you, Dr. Raju. And all the scholars, those who have attended, we hope that in future we'll meet again for the next conversation. Bye-bye. Take care.
Nice. Thank you. Shall I leave, sir?
Yes, yes, yes.
Yeah. Okay. Thank you.
एक से किसी कर दे देखिए इसमें क्या था ना
जो आपने भेजा था लिंक उस पर तो आया है ना सारी चीज यही सेम चीजें आपने भेजा था कंपनी और ये सारे बना के तो उसी को डायरेक्ट डाउनलोड क्यों ना कर ले
कौन कंपनी भेजा था
आपने लिंक भेजा
अरे नहीं इनको कॉन्सोलिडेटेड चाहिए था सर जैसे ये है ना ये डिलीट कर दो ठीक अब अपना किस कंपनी का लेना है देखिए
नीचे
व्यू नीचे ये था ना, पीडीएफ को हटाना था। न्यू टाइप साइज टाइप, जैसे था ना एक्रोबैट, इसको डिलीट करना था मेरे को, डिलीट कर दिए थे। चलो डॉक्टर साहब, क्लियर। टाइप ठीक, हम लोग यहाँ तक चले गए 26 वाले, यहाँ से इनका ये वाला फाइल था, खुला हुआ है, कौन सा, ऑटो कैड 28 है ना, 28 ऑटो कैड यहाँ चल रहा था, है ना। अब 24 एंड 25 अगस्त ये था, इसे चेक कर देखो किस कंपनी का है।
गुड इवनिंग अजय सर।
ये दूसरा का है, ये वाला
आई एम
है ना,
ऑडिबल टू यू?
ये दोनों एक ही है, रास्ता, इसको डिलीट कर दो। ये मेरा 25 का ये है, तो 25 का नंबर ले लिया,
ये नो
25 अगस्त ना, इसमें पेश कर दिया, है ना, ठीक। अभी अभी क्या फॉर्मूला यूज करना था इसके लिए, फॉर्मूला ही नहीं तो फॉर्मूला तो लग के समझा दिए, कौन सा बिल लगा था, मैं बोला था लिख देने यार नीचे फॉर्मूला को।
नहीं एक्चुअली सर मेरी एग्जामिनेशन इन्विजिलेशन ड्यूटी थी।
अरे हैंग कर जाएगा, बोला ही फॉर्मूला तो लीजिए, तो काम का साला हैंग कर जाएगा ये।
एंड मैंने 12:30 बजे ज्वाइन कर लिया था,
ले चले उसी के पास।
और आपने बोला था उसके बाद 2:30 पे ज्वाइन करना है।
अच्छा, पेन ड्राइव में वो लिखा ना, लिखना लिखा था बोला,
लिखा था फॉर्मूला,
पेन ड्राइव में लिखा था।
सही कहा था मुझे पर, हाँ वर्ड में लिखवा लेना चाहिए था ना।
सर बताइए।
ये आइए चेक करो, और इसका वो तो बता दिया कौन सा यहाँ तो मैं कॉपी कर लिया, फॉर्मूला तुम लिखे नहीं था,
फॉर्मूला लिखा था सर।
कहाँ पे,
अरे लिख देता हूँ, ये कॉपी पेस्ट है ना सर।
हाँ अभी मैं यहाँ कर दिया,
इसका फॉर्मूला बस यहाँ पर एक जगह लिख लीजिए, नोटपैड में लिख के रखिए, कॉपी पेस्ट करते रहिए। ये फॉर्मूला ये है ना, लुकअप और हमें सर्च करना ही है, कॉमा, इसमें सर्च करना, इसको यहाँ नीचे तक ले लीजिए, फॉर्मूला आपके लिए कॉमन हो जाएगा, डेटा मतलब नीचे तक है ना, यहाँ तक ले लीजिए, नीचे नहीं यहीं तक, बजा नहीं जितना जितना था, ठीक है यहाँ तक। इसके से क्या हो गया, आएगा तो 1 और फॉल्स, ठीक है। और यहाँ से डॉलर
जब काम करें तभी फोन आता है। डॉक्टर साहब
फॉर्मूला इस तरीके का होगा आपका।
लग गया ना कोई पीछे, और वही घरे से फोन आएगा जब काम रहेगा तब घर
से बाहर से है ना।
है डॉक्टर साहब।
हेलो, हाँ हेलो हेलो, हाँ बोलो, आगे डेटा ही। अब ये आगे फॉर्मूला आपको कॉपी करके रखना,
नहीं कॉपी कर दिया, व्हाट्सएप पे copy।
ठीक है। ये फॉर्मूला कॉपी कर लीजिए ना, नोटपैड में। हेलो, हाँ बोलो, हाँ कुछ काम कर रहा हूँ, बताओ। मालूम, अगर वो बोला वो भी खाओ, ठीक है। हाँ, अरे जाओ, अभी ये हो गया ना आपके पास।
हाँ ये आ गया।
फॉर्मूला ऐसे सभी में करना, डेटा बस आप पेस्ट करते जाइए।
हाँ
डेटा बस पेस्ट कर दीजिए, सब
हाँ,
डेटा यहाँ पे
आ
आते
जाएगा
जाएगा।
ठीक।
तो यहाँ फिल्टर लगा करके, ठीक है।
फिर फिल्टर किस लगाना?
फिल्टर, यही फिल्टर
हाँ
आपको वन करना है ना।
हाँ हाँ
तो वन करना है तो जीरो को हटा देंगे तो काउंट है, नीचे वाला है ना।
हाँ,
ये भी हटा देंगे, ये भी हटा देंगे, ठीक है। तो ये नंबर है जो मिला है हमें,
मिला है।
इसको हमें वन करना है। तो यहाँ पे वन लिख करके क्या कर देंगे, वन लिख करके यहाँ पे डबल वन हो गया।
क्या करिए, कॉपी कर दिया सब जगह।
वन वन कर दिया।
हाँ हाँ
आपको वन चाहिए था ना जो प्रेजेंट है।
हाँ हाँ
अब यहाँ पे आप सेलेक्ट करोगे एनए, एनए सेलेक्ट करोगे, ठीक है। और यहाँ पे इसको सेलेक्ट करके कंट्रोल, इसको आप डिलीट कर दोगे, डिलीट हो गया ये, ठीक है। तो सेलेक्ट ऑल करोगे तो आपको मिल जाएगा वन वन कौन सा वन वन, देखिए नीचे यहाँ पे आ गया होगा, है ना। देखिए वन वन कितने हैं टोटल,
सुपर
टोटल 4 है।
हो गया।
इस तरीके से और भी सब करना है।
एक एक डेमो दिख सकता हूँ ना मैं।
कर लीजिए।
ये तो हो गया।
हाँ, और भी करीब हटाओ। क्या कर रहे हैं, डिलीट, हाँ डिलीट करिए करिए, यही फाइल खोलिए। कौन सी फाइल और करना चाह रहे हैं।
ये वाला है ना 24 का है ये।
24 तक नीचे कॉपी पेस्ट, वापस कर दिए, गलती से कॉपी कर दीजिए, दो सी, वहाँ पे जाइए 25 वाले, वहाँ पेस्ट करिए, कंट्रोल V पेस्ट कर दिए,
ये यहाँ पे चेंज हो गया ना।
एंटर। अब
जैसे
वो कर दिए, डबल क्लिक कर दिए,
है?
चेंज कुछ नहीं हुआ। आप बस आउटपुट आने की जगह चेंज हुई है, सोर्स हुआ वाला और दूसरा सोर्स सेम ही है, उसमें कोई अलग डिफरेंस नहीं है।
ये तो हो
वो
गया।
वाला सोर्स
हाँ।
और ये वाला सोर्स तो सेम ही है ना।
क्लिक कर दूं, डबल क्लिक
डबल डबल नहीं, यहाँ पे क्लिक कर,
यहाँ पे।
हो गया।
हाँ
और
अच्छा,
यहाँ
ऐसा हाँ इस सेम कैसे बॉस? C2।
C2 उधर है आगे वाला,
हाँ C2 हो गया। और
जेड
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 हाँ।
जेड जेड टू यहाँ पर है,
जेड का हाँ $2 है ना।
जेड
जेड इतना।
नीचे तक है वो डेटा, मतलब नीचे तक
अच्छा
लेगा।
हाँ, कोई दिक्कत तो है नहीं,
कोई
तो हो
दिक्कत
गया।
नहीं है, फॉर्मूला सही, फॉर्मूला कोई चेंजेस नहीं करना। अब यहाँ पे देखिए कई आया ना, कई डेटा जो जो
हाँ।
जो प्रेजेंट था उसका क्या आ गया, आपका एडमिशन नंबर आ गया।
अब यहाँ पे
जीरो का सेलेक्ट करिए, नीचे जाइए, एन को सेलेक्ट करिए, ब्लैंक को सेलेक्ट कर, ओके कर दीजिए। अब यहाँ पे वन लिखिए,
यहाँ पर
वन लिखिए,
हुआ।
हाँ डबल क्लिक करिए, पहले वहाँ बाहर क्लिक करिए, बाहर,
है ना।
हाँ हो गया। फिर वहाँ क्लिक करिए, इस पर क्लिक करिए फिल्टर पे, फिर यहाँ पे
17
एन क्लिक करेंगे।
अच्छा टोटल
17
होगा।
टोटल होगा। हाँ, क्लिक करिए, उसको सेलेक्ट करिए नीचे तक।
हाँ क्या करना
नीचे तक जाइए,
यहाँ क्लिक कर देना वही तो
नीचे तक। हाँ, हो गया, इसको डिलीट करिए। डिलीट हो गया, फिर वहां जाइए। अब हो गया। सेलेक्ट ऑल करिए ना।
अच्छा सिलेक्ट वाला पूरा
हाँ,
दिखाओ पूरा दिखाओ
पूरा दिखाओ। बन गया डेटा।
वो नहीं दिखाओ।
हाँ, नीचे तक आइए, नीचे तक आइए, फिर आपका डेटा सही आ गया। तो नीचे तक आइए, 17 काउंट, डेटा सही आ गया। अरे सर, हो जाएगा सर। आप अधिकारी आ गया, आप लोग लिखना होगा। हाँ, उनको सर खिलाइए, संतोष सर के साथ खाएंगे, अकेले नहीं खाएंगे।
सर को तो मैं इतना पकड़ता कि तो भागे रहते हैं हमसे पूछो। डॉक्टर साहब एक पिज्जा पार्टी खाते हैं सीधा।
हाँ, संतोष सर के साथ अकेले नहीं।
अरे वो तो भाई डिफॉल्ट रहेगा मेरे मंजूर भागते रहते हैं डॉक्टर साहब। कभी ऐसा हुआ है हम तो इनको पकड़ते रहते हैं। हाँ तो बनाना चिप्स भी पकड़ रहे थे तो भाग रहे थे क्लास।
नहीं, क्लास आए अभी तो
सब पानी पिलाइए मसाला बोतल से। इस वक्त टाइम दिया इतना देर में टाइम दिया और चलो साफ करना खाना भी नहीं खिलाया।
दिखता लगे लड्डू की सोफा
उनका था तो उनका तो खाने का बिल्स में था। सही डॉक्टर साहब थैंक यू सर थैंक यू डियर। अरे छोटा भाई अब तो आपसे बहुत कुछ मजा लेना है। ठीक करिए डॉक्टर साहब। सबमिट कर दिया। हाँ किसको
हाँ जी, आपका हो गया सेशन से
अच्छा करते हैं
हो गया खत्म।
डीन के पास चला हाई हेलो करता तो डांटेगा। हम लोग सब कुछ कर दिए सर कितना काम था
हाँ
एक्सचेंज हुआ ना हमको बोला था कल तक देना है। तो हम लोग आराम से
चलो।
कर रहे थे। चलो सब काम देखो डॉक्टर साहब कितना कितना काम कर
उठा
दिया।
लें
हाँ?
उठा लें
हाँ, हम बताएंगे डॉक्टर साहब कितना जेन्युइन वर्क कर रहे हैं डॉक्टर साहब।
एक एक लाइन चलो उठ तो पहला पूरा बजाते किस डेट में कौन सी। अभी थोड़ा डिंग तो मारना पड़ेगा, मैं जो क्वालिटी क्वालिटी चिल्ला रहा था इससे अच्छी क्वालिटी का हो सकती है। कहाँ गया? हाय, अरे थैंक यू। हाँ, आज बिजली गिरने वाली है, अभी जाते हैं उसको
अच्छा टोटल
हटाने।
90 डेज का क्लास होता है ना सर 7 शिफ्ट का
है
मतलब 15 दिन में हेलो हाँ? मतलब 20 दिन बच्चे बोले कि सर लगभग सभी बच्चे 20 दिन को अटेंड किया
टुकड़े किए हैं।
है ना।
हाँ, एक्स्ट्रा क्लास लिए हैं। चलो चलो बोलेगा, हाँ हाँ बोलने का हिम्मत है। पीछे पीछे बैठ जाओ। हाँ
Yes, sir.
हो गया। अरे कहाँ गया आपका डेटा, किधर गया?
Data.
पहले खोल खोल लो, फिर वहां जाने के बाद ये तो डेटा है वो वाला सेव किए हो ना।
Mm-hmm.
बंद करो, पेन ड्राइव भी खोल लो। कंट्रोल पैनल है वो खोल लो, भाई कंप्यूटर ना। हाँ, पेन ड्राइव ये डेटा खोल लो। ये साला ऑटोमेटिक चल रहा है बिना चले हुए। धीरज किस चीज की
हाँ जी हाँ जी।
Ajay sir. Ajay sir. सर मेरी प्रेजेंटेशन नहीं हो पाई थी। आपकी आवाज नहीं आ पा रही है, आपने अनम्यूट नहीं किया अपने आप को।
Now is it okay, sir?
यस
Ashik
सर,
sir,
यस सर, बिल्कुल।
I have submitted report that we have been detected तो आप presentation दे दो था recording के लिए, है ना? मैंने
हम्म,
आपको report submit कर दिया in positive way. So don't worry about only for formality that complete that one.
ठीक है सर, ठीक है। अब मुझे कोई करना तो नहीं है मेरे साइड पे।
नहीं मैंने भेज दिया रिपोर्ट कि आप आए थे and
हम्म,
it is submitted and everything is okay and everything he presented very well like that.
ओके
चलो ठीक
सर,
है ना? So don't
राइट
worry.
सर। सर कब तक हमें मिल जाएगा सर्टिफिकेट इसका?
2 दिन में मिल जाएगा, आप कांटेक्ट में रहिएगा। मैंने रिपोर्ट सबमिट कर दिया आपका सब कुछ।
ठीक 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 है सर, ठीक है सर। आप अपना नंबर दे शेयर कर दीजिए।
हाँ प्लीज नोट इट 99580।
1 मिनट सर। राइट सर, 99580
77063
77 66 0
99580 77063।
063, राइट सर।
Okay, have a nice day.
ओके ओके सर, थैंक यू सर।